Good morning. Welcome to the part of season 2 in the Keio International Christian University Linguistic Colloquium. I'm Seunghun Lee from International Christian University. Today we have two exciting talks by Katie Franich from University of Delaware and Laura McPherson from University of Dartmouth. Let me first introduce Katie, the first speaker of today's talk series. Katie is currently an assistant professor at University of Delaware, and she received a PhD from University of Chicago in 2017. Her research focuses on speech acoustics, articulation, and perception in order to understand how language is structured and how it's learned and how it gets passed on from one generation to the next. Katie, it may sound very familiar to you. Much of her work draws on data from Medumba, a Grassfield's Bantu language spoken in Cameroon. And she has been working on the language since 2010. Also, I want to add congratulations to Katie for receiving a grant from the National Science Foundation to fund a project titled Speech and Communicative Timing Across Languages and Linguistic Contexts. Today, Catherine will talk about rhythmic alignment in Medumba language and song, the role of metrical foot structure. Let's welcome Katie. I will stop sharing my screen.
Thank you, Seunghun. I'm going to go ahead and share my screen. All right, great. And I just want to say if any of this interests you, any of the work that I'm presenting today, please feel free to reach out as a part of that grant that Seunghun just mentioned. I'm going to be bringing on a postdoc to start in September of 2021, and also a graduate student. So feel free to get in touch if you're interested. So I'm going to tell you a little bit about my work looking at metrical structure and rhythmic alignment in Medumba. And I'll start by introducing this debate about whether or not all languages can be said to have metrical prominence asymmetries, otherwise known as word level accent. And at one kind of end of the spectrum in this debate, you have people like Goedemans and Vanderhulst who argue, as a working hypothesis, we might assume that all languages have accent. And at the other end of the spectrum, you have folks like Larry Hyman, who argues it'll be extremely difficult to demonstrate to the satisfaction of all that word accent either is or isn't universal. So too hard to tell. And just to kind of clarify a little bit of terminology here, I'm going to be using the word accent in the sense of Vanderhulst 2011 to refer to the locational aspect of prominence at the prosodic word level or a unit of a similar time scale. So independent of acoustic properties. And then stress is going to be used specifically as a phonetic correlative accent. That's how I'll need it here. So I'm going to be talking to you today about Medumba, a Grassfield's Bantu language. And the reason that I'm going to focus on Medumba is, number one, that many African languages, including Medumba, kind of lack unambiguous evidence of stress or metrical prominence. So they provide this kind of interesting, challenging test case for the idea that word level accent is universal to languages. On the flip side, languages like Medumba and many other African languages do show phonological patterns which seem to point to elevated prominence of certain syllables. In this case, we're going to be focused on stem initial syllables versus non-initial and non-stem syllables. So the talk is going to be broken into two parts. In the first part of the talk, I'm going to present on some speech production experiments looking at rhythmic alignment patterns of stem initial versus non-initial syllables in this language. And then we're going to sort of take the findings from that experiment and go on to explore patterns in Medumba speech-based music, patterns of text setting, and how metrical structure is implicated in those patterns. Just a little bit of info about the language. This is a Grassfield's Bantu language spoken in Cameroon by about 200,000 speakers. Arguably, Medumba is descended from Proto-Bantu, but it has a more isolating morphological structure than some of the kind of better known Southern and Eastern Bantu languages. It has very few affixes, and in the place of those affixes, it has lots and lots of tonal morphology. And here's just a map of Africa so that you can see where Cameroon is, highlighted in red on the west coast. And then we've sort of zoomed into this green area here, which is West Province, where Medumba is spoken. Or West Region, I'm sorry. So this Mijumba is one of many languages kind of situated in the northwest region of sub-Saharan Africa that demonstrates this pattern of what's been referred to as stem initial prominence. So languages from a variety of different language families, Niger, Congo, and actually beyond, show this pattern where stem initial syllables realize the full range of consonant and vowel contrasts, whereas non-initial and non-stem syllables realize only a subset of these contrasts. So in the case of Mijumba, only schwa and a subset of consonants. So here are the actual patterns, and what we're contrasting is what's in the blue box, so all of the consonants and vowels that are available in stem initial position versus what's in the red box, what's available everywhere else. And you can see that's a much reduced set. And so the question that we're interested in here is, are these asymmetries associated with metrical accent? And so we have some other kind of clues that metrical structure may be implicated in some of these patterns. So some of the asymmetries in constant contrast that we see are driven by this process of lenition. So specifically, for one example, velar stops will lenite, they will spirantize and voice intervocalically, but only in certain positions. So for example, we have the verb stem release, where we have kaga instead of kaka. So we have lenition occurring stem internally there, or word internally. We can also attach a pronominal enclitic to the stem, and we still get lenition in those kinds of contexts if it's a VC shape pronominal enclitic. If we, however, place this verb stem in front of a proper noun or another prosodic word that's vowel initial, we don't get that same process of lenition occurring, so we get kakange instead of kagange. And likewise, stem initial consonants do not lenite even when they occur word internally. So if we were to concatenate this infinitival prefix to this verb stem, we would get nekaga as opposed to nagaga. And so to the structure that we might propose to capture this, we could say that the stem is basically isomorphic with a foot, and then we could attach this prefix via something like prosodic word adjunction to get a prosodic word. And then the generalization becomes that K lenites intervocalically within a foot. So in summary, from what I've told you so far, stem initial or maybe foot initial syllables carry more consonantal and vocalic contrasts. They also carry more tonal contrasts. I haven't shown you data for that, but you can take my word for it. And they also resist lenition. So one kind of confound in jumping immediately to the conclusion that we've got a pattern of stem initial metrical prominence here is that word initial and stem initial, foot initial position, domain initial position in general of various different prosodic units is known to be targeted for various types of processes like fortition. And so these processes that I've just shown you could be driven by metrical prominence asymmetries, but they could also be driven by just the fact that these syllables realizing full vowel contrasts are in word initial position, or even that they are in foot initial position. So not necessarily indicative of a metrical prominence asymmetry per se, in the kind of rhythmic sense. And so taking this as the sort of background, I'm going to present to you some experiments which are meant to explicitly test for rhythmic prominence of these stem initial syllables. And specifically, the paradigm that I've used is called the speech cycling paradigm. It was developed by Fred Cummins and Bob Port in the 90s. And the paradigm has subjects repeat short sentences in time to a metronome. And the interesting finding across different languages, a typologically diverse array of languages, we find that stressed or accented syllables or moras are found to align with specific phases of the repetition cycle. So halfway through the cycle, 1/3 of the way through the cycle, or 2/3 of the way through the cycle tend to be the places where we find these syllables aligning. And this task has been carried out in a variety of languages, like I said, in Korean, in Japanese, in Jordanian Arabic, in Brazilian Portuguese, and in English. So in the English case, we would take a sentence like dig for a duck, for example, is one that's been used. And I'm going to clap my hands, and you can imagine that I'm a metronome. And the way that people approach this task in English would be to say, dig for a duck, dig for a duck, dig for a duck, dig for a duck, dig for a duck. So I've just started clapping my hands double time to show you that duck is occurring basically halfway through the repetition cycle that I was initially clapping. Another pattern that people gravitate towards is this one, dig for a duck, dig for a duck, dig for a duck, where duck occurs a third of the way through the repetition cycle. And then finally we get dig for a duck, dig for a duck, dig for a duck, where duck is occurring 2/3 of the way through the repetition cycle. And these are overwhelmingly the preferred modes of operation in this task. And the way that this has been captured theoretically is by basically recasting the traditional prosodic hierarchy that you have over here on the left-hand side of the screen. So the prosodic phrase, phonological phrase, feet, syllables are recast as a series of coupled oscillators operating at different frequencies. And these oscillators are phase locked and frequency locked to one another. So we can capture patterns of binary feet by proposing a 1 to 2 phase locking coupling relation between syllables and feet, and we can capture ternary feet by having a 1 to 3 phase locking pattern between syllables and feet, frequency locking pattern, I should say. So the question then, in the context of this task, is whether or not stem initial syllables in Majumba show similar patterning in speech cycling to stressed or accented syllables in these other languages that I've mentioned. And so the sentences that I used in the task, these Majumba sentences, they're all 4-syllable sentences. And in this first experiment, I'm comparing the final syllable in these sentences. So we've got men chakmbipa, so the child lost the bicycle. So this final syllable here is just a monosyllabic noun, and this is, I should say, this would be considered both stem initial and stem final, technically speaking, but because monosyllabic nouns realize the full range of vocalic and consonantal contrasts, as I showed before, we will consider this to be stem initial for the purposes of this experiment. And then in the second condition, we have in 1B, men chakmbiba, where this final syllable is the second syllable, the truly stem final syllable of this verb to wait. We'll also compare the penultimate syllable across these two conditions, which in both cases is stem initial, so we don't necessarily expect any difference in alignment for those syllables. And then in a second experiment, I compared constructions like these, men then nitsi, the child knows how to choose, where the penultimate syllable is a prefix, the infinitival prefix, versus men then nutsa, where the penultimate syllable is a noun, monosyllabic noun, and is stem initial. And so we do expect there to be some alignment difference here. So there were 14 subjects that participated across the 2 experiments, and they repeated 3 different sentences per condition. These sentences were matched across conditions for their phonetic content, and they repeated these sentences at up to 15 different speech rates, which was controlled by a metronome. And the predictions that we have are that stem initial syllables should be more likely to cluster around the simple harmonic phase positions, a third of the way, halfway, or 2/3 of the way through the metronome cycle, or through the speech repetition cycle, I should say. So 0.33, 0.5, 0.67, if we're dealing in decimals. And then stem final and non-stem syllables should occur farther from these positions. And we're predicting that these syllables should actually be parsed with what comes before them in a foot. And if you want to talk more about that in the question period, I'm happy to say more if you want to know more. So here are the results for the first experiment. So you've got our target sentences up here in the upper left-hand corner. The blue lines are going to refer to stem initial syllables, and the red ones to stem final syllables. So the penultimate syllable in these sentences, remember, was stem initial in both cases, so we didn't necessarily expect there to be an alignment difference there, and indeed we don't see any alignment, any significant difference in alignment overall for those syllables. If we move to the fourth syllable, where we had a stem initial syllable in the first condition, stem final in the second, we did expect a difference, and we did in fact find a significant difference in alignment. So the stem final syllable was realized significantly earlier than the corresponding stem initial syllable in that position. On the right-hand side of the screen, I have these distributions, and I can talk more about what they are representing in the question period, but just briefly, what you are meant to take away from these is the relative location of the major peak in the data for each of these syllables relative to this dotted line, which in each case is representing the closest harmonic phase position to that syllable being repeated. So in this case, this is a third of the way through the cycle for both of these, and you can see that this peak aligns very nicely with that position. These are both stem initial syllables, as indicated by these blue outlines. So these are these two syllables, respectively. Again, syllable 4 here in this condition here, we could look over here at its distribution, and we see that this peak aligns again nicely with a harmonic phase position. It's the halfway point of the repetition cycle. And then finally, this syllable here, this stem final syllable, is the one syllable that doesn't seem to align its peak very well with the closest harmonic phase position. So that peak sort of occurs between two dotted lines here. So that's experiment 1, and then looking at experiment 2, we were comparing the penultimate syllable here, which was stem initial in this condition, and a prefix in this condition. We did find a significant difference in their overall alignment. And then if we look at their the alignment of these syllables with respect to the harmonic phase positions, we see a nice alignment here of the stem initial syllable with the third of the way through the repetition cycle harmonic phase position. But this syllable, the prefix syllable, occurs quite a bit earlier than that closest harmonic phase position. So in conclusion for this part of the talk, stem initial syllables were, as predicted, attracted more strongly to these prominence attracting positions in the repetition cycle than non-initial and non-stem syllables occurring within the same numerical position, ordinal position. And these patterns resemble the ones that have been found for stress syllables in languages like English, which show clear phonetic evidence for metrical structure. And so this similar behavior in speech cycling across languages suggests that stem initial prominence also reflects rhythmic prominence in Majumba, which is consistent with the idea that this is sort of true metrical prominence and not just a domain edge effect. So moving on now to part 2, we're going to sort of take some of the knowledge that was gained in the first part and delve into another area where metrical prominence asymmetries tend to play a major role, and this is in text setting in music. So musical rhythms have long been used as a window into aspects of metrical structure and timing. They were really kind of a foundational part of the development of metrical theory, of metrical phonology. And the mapping of stressed or metrically prominent syllables to musical beats appears to be constrained across a very diverse array of languages and artistic traditions. So metrical structure seems to play a role in these patterns of text setting, of matching text to music. So I've taken one example here that's familiar to me and that may be familiar to other native English speakers. So this is Old MacDonald Had a Farm. This is a song that every kid growing up in the United States learns to sing. So one of the cool things is that you can swap in different animals in the second measure here. So you can have, for example, on that farm he had a gerbil, E-I-E-I-O, or on that farm he had a giraffe, E-I-E-I-O, gerbil bearing initial stress, giraffe bearing final stress. And you'll notice that, at least for my intuition, the rhythm of this second measure is crucially different depending on which of these animals you swap in. And basically the goal here, at least for sort of my musical grammar here, is to map the stress syllable to one of the odd number beats in that measure. Not everybody might share that same intuition, and I'm really curious to hear if you don't share that intuition later on. But the sort of take home is that there's some rhyme or reason to how we map these things to this musical line, and generally speaking, stress is going to play a role in determining exactly how that works. So the question then is, what role does metrical structure play, if any, in the alignment of syllables in speech-based music in Majumba? And this is joint work with my collaborator, Dr. Anj Bergson-Lendja, and he is a native speaker of Majumba, and he's also from the area where we have been collecting data for this project. So our corpus so far is these 2 Majumba folk songs that were recorded in his native village of Bangulap, and specifically in the quarter called Lampen. These songs both are played in a sort of traditional way within an ensemble that consists of percussionists led by a master drummer who interacts in call and response form with community members as they dance around the drummers. So far we've transcribed just a few of the instruments that are actually present. I'm going to play you a clip of some of this music in a minute. And you'll notice that not all of the instruments are represented, but we've transcribed rhythms for some of these, including the menfama, which is the master drummer's drum. So in this picture, it's actually the one that's on the ground here, and we actually have not transcribed the other rhythms yet, but we're focusing here on the master drummer's drum. The ndunlam, which is a glockenspiel made of iron, the ndo or whistle, and the ncha, tin shakers. It's a nice little idiophone for you. And then the voices of the master drummer and the dancers. So as far as how we went about this, we made the decision to work within Western musical notation and interpret these songs in terms of time signatures. Specifically, the first song is going to be interpreted as in a 2/4 time signature, and the second in a 12/8 time signature. We certainly can talk about the limitations of trying to interpret music from this region using these tools that were developed in a different context. But there are a number of music theorists, including music theorists from this region, from Central and West Africa, who do adopt this approach. And so we've opted to do that for just for the ability to kind of compare across this context and other contexts. And then basically we examined how syllables in various positions within Majumba words aligned with the overall rhythmic structure of the songs. So I'm going to play you a bit of the first song here. And this clip is nice because it's at the beginning of the song, and you'll see the different voices kind of joining in. So we first hear the master drummer kind of calling out and beginning to sing. And then we hear the ndunlam, the glockenspiel come in, and then the master drummer starts to drum. You can hear one of the dancers starts playing the whistle in the background. And then finally the shakers, the guy with the ncha kind of steps in. So I'll play you a little bit of that. Just beware, I've tried to adjust the volume so that it's not too loud, but just be careful with your ears.
Somehow the sound is not playing. Yeah.
I don't know if Katie heard it.
We couldn't hear the sound.
Oh, you can't hear the sound? Oh no. Oh gosh. Hold on 1 second. Let me stop sharing and share with sound.
Yeah.
Sorry about that. See if you can hear it now.
Yes.
Can you hear that? Okay, great.
It's the tip. It's the tip. And when I will start, you will do the same. Yeah. I'll give you that.
So that's the first song, and this is part of that, so just an excerpt from that song, and note that the rhythms do change some throughout the song, so these may not be exactly the ones that you've just heard. But just to kind of give you an overview, you've sort of got these two lines here from the Ndudlam and the Necha, which seem to play a pretty regular rhythm throughout. You can maybe think of these as sort of forming the kind of rhythm section. And then the Menfama, the master drum, is playing a slightly more complex and changing pattern. And the Ndo is playing a pretty regular pattern, but that deviates some from the other instruments. And then we go down to the voices down here, and in particular, the dancer's voice is the one that I've represented here, and then the master drummer kind of comes in over here. And I've highlighted in red all of the stem initial syllables that appear here, and in green any affixes that occur, and then the remaining things are left in black. Those can be pronouns, focus markers. We've got a variety of things here. And now I'm going to introduce these little stars, which are meant to mark off basically the beginnings of beats. Okay, so this is again in 2/4 time signature, so we'll have at most 2 stars per measure. I've only marked stars where we actually have a note that begins on that beat. And so you can see that these stem initial syllables really like to occur where there's a star directly occurring over them. Affixes tend to occur on places where there are not stars. And then focus markers likewise tend to occur where there are not stars. And pronouns can kind of go either way. They can kind of occur with stars, or in some cases without stars. The dancer's voice basically repeats the same rhythm essentially throughout the whole song. The master drummer's rhythm is going to change a little bit in what he's singing from verse to verse. He kind of will be a little bit more variable. So that's the first song. And now I'm going to play a little bit of a second song that's we've notated it in a different time signature. This one we've notated in 12/8. I'll just play a little bit so that you can get a sense. All right, so that was the second one. And here's part of our notation for this song. So in this case, we've got 12/8. So basically, you've got sort of 4 main beats that the Necha is beating per measure. And then the Dunlam is kind of subdividing those up into groups of 3. And then we've got the kind of more complex rhythms going on up here for the master drummer and the whistle, the Ndo. And again, I've marked in red the stem initial syllables, and in green, any affixes. And I'm going to show you those stars again. So this time we've got a maximum of 4 stars occurring per measure, 1 on each, the beginning of each of the 4 beats. And you can see again that these stem initial syllables tend to really like to occur where those stars are showing up, and these affixes tend to like to show up in other positions, basically fractions of the beat that are not at the beginning of the beat. So we've got, and then things like pronouns again are sort of occurring usually on fractions of the beat, although pronouns are a little bit more flexible in where they show up. Here's another line. In this case, we've got stem initial syllables marked in red, stem final syllables are marked in blue here, and then affixes in green. And once again, you see the stem initial syllables are lining up with these stars. And these affixes and these stem final syllables are basically occurring on these fractions of the beat elsewhere. So here's a kind of breakdown for the different beats across these two songs, what types of morphemes or syllable types were occurring on these different beats. And so I've broken it down into even numbered beats, odd numbered beats, and then fractions of the beat. So any place that wasn't the beginning of a beat, but that was maybe the second third of a beat or the last third of a beat. And so there's a couple things to notice. First off, the dancers in their sung portions often like to align the stem initial syllables with the beat, as I had pointed out earlier, but they especially seem to like to align them with even numbered beats, especially to the 2 in a 2-4 pattern, or to the 2 and the 4 in that 12-8 pattern. And then if we go over to the master drummer, we actually have kind of a reversal of that pattern, where most of the stem initial syllables are occurring on the odd numbered beats, and we have more of a mix on the even numbered beats, although still a lot of stem initial syllables occurring there. And then the green represents pronouns in both of these cases, accounting for the rest of the proportion that wasn't a stem initial syllable. And then for both of these voices, we find that fractions of the beats were largely occupied by affixes, focus markers, and pronouns. So these other things that I had pointed out to you, but fewer stem initial syllables. The blue again is stem initial. Fewer stem initial syllables, especially for the dancers, more for the master drummer than for the dancers, occurring on those fractions of the beat for stem initial syllables. So, so the kind of takeaways that I'd like to highlight here are, first, that coordinated properties of metrical structure in Majumba are evident both from the speech cycling experiments and also from these text setting patterns. So we saw that stem initial syllables seem to be preferred in certain positions within the musical line, as they are preferred in certain relative phase positions in the speech cycling task. Text setting in Majumba, just as in lots of other cultures, involves this interplay of linguistic structure and expression. So the fact that the master drummer seems to have different patterns from the dancers, who tend to be more consistent across different verses within the song, I think is a testament to the fact that the master drummer is sort of the creative centerpiece of the group, and is able to take more liberties basically with his the structure of his lines. We also observe some cross-cultural variation in exactly how speech may be coordinated with a rhythmic line. And again, you know, whether it's even right to be sort of thinking about these rhythms using Western musical notation is an issue unto itself. But if we're going to do that, then we can see that that my intuitions about where stress syllables go in the Old MacDonald example that I gave earlier, occurring on odd numbered beats, is sort of different from what we see here with stem initial syllables being preferred on these even numbered beats. So some variation there that exists. And then to kind of zoom out a little bit more, given the variety of ways in which metrical prominence can be manifested phonetically across languages, so we see a lot of different types of correlates to metrical prominence across languages, including just even among languages that have stress. Coordinated patterns may actually provide a kind of nice unifying property of metrical prominence across languages when these other kind of phonetic properties are sort of variable. And this accords with something that Vanderhulst et al. Have kind of argued for, in that they've argued that phonetic and phonological correlates of rhythmic prominence at the word level arise through grammaticalization of what they refer to as low-level rhythm, which they take to be a universal property of languages. And it's not entirely clear what they mean by low-level rhythm, but it's entirely possible that these kind of coordinative properties are exactly what constitute that low-level rhythm that then becomes kind of grammaticalized in these various ways. And that is actually an interesting question, I think, to consider from this perspective, why it is that languages do develop the specific correlates of metrical prominence that they do. And that's kind of another question for another day. And with that, I will conclude. Thank you very much for listening, and malapta zina.
Thank you. No, that was really exciting. you get also applause now. Yeah. So please send me your name. If you have a question, please send me your name to Seunghun Lee as a private message. Then I will call you if you have a name. Not if you have a name, you of course have a name. So if you send me your name, and if we haven't got any questions yet. So if I may ask one question, I was
Sure.
just wondering, like in this focus position, you said it was a fraction of the beat, but I think at least in the 2 or 3 focus phrases, what I saw was there was a tie to the longer beat that follows. And I don't know, I wonder whether you have any thoughts about that particular, maybe it was a coincidence that the focus happened to be in the 4th beat, and then it ties to the next measure, basically. But
yeah, absolutely. Yeah, no, it's a good question, and there's a lot more to say, I think, about the ways in which syllables are getting mapped. So the focus marker carries a falling tone, and so that is one of the reasons why I think this morpheme likes to take up more than one fraction of a beat, and why it ends up kind of tied over that way. Why it ends up in that particular position, I mean, this may be sort of song specific in this case, but definitely I think there is a pattern by which morphemes bearing contour tones tend to take up more rhythmic space, more beats. Yeah, which sort of makes sense if you think that, you know, contour tones like heavier things, or you know, bimoraic things.
Yeah, thank you. We have some questions. Kane and Bryce from UCLA. If you want, you can turn your video on and then ask the question.
Hello.
Hello.
Hello. My Zoom seems to have frozen, so I'll just not worry about the video. Oh, here we go. You're over there, by the way, so I'm not trying to look away. Weird adjustment in Zoom land. I was just curious about the methodology of the metronome experiment. So I assume there have been, like, given that one of the hypotheses is that stress or rhythmic prominence is universal, like, we can't say, well, are there languages that have had this technique used and found null results for stress, right?
Yes, right.
Like, can you verify that there are some things that just don't align?
Yes, yes. So I would say there's a couple of different parts of the answer that I would give. First of all, I think that in probably any language, you're going to find something that aligns. Whether the thing that aligns is sort of aligned with what we think of as being the thing that we want to say is the metrically prominent thing is another question. I think there's been a lot of sort of debate about this in languages like Turkish, where you have stress occurring in a particular position that doesn't seem to be necessarily foot-based, but maybe we have evidence for foot structure from other types of processes. And I think that's an interesting question to see what the relative contribution of each of those types of things might be. I would imagine still that metrical prominence is going to play a role beyond stress in those cases, but there may be some sort of competing pressures there. Does that answer your question?
Sort of. I'll think about it. Thanks very much. That's really cool.
Yep, thank you. Next question is from Shigeto Kawahara, Keio University.
Hi, this is really cool. This is kind of a study that I want to show my students because a lot of them are interested in music as well and how they interface with linguistics. My specific question is, I'm looking at the distributions on slide 32 and 33. Yes.
Okay.
The results of experiment 1. So let's look at 32.
Mm-hmm.
If you look at panel 3, it looks like, I mean A, 32A, looks like it's a combination of 3 distinct distributions with 3
Right.
peaks, right?
Yes.
Whereas the suffix is really unimodal. So there's a sense in which the stem initial syllables are aligned with these 3 different time points,
Mm-hmm.
whereas suffix is literally more random. So yeah.
Do you mind sharing your screen, Katie, when you respond? Yeah.
Yes, sure. Yes, let me, sorry, yes. I should have done that before. All right, can you see that?
Yes.
So yeah, so you're referring to the fact that there are
Yeah,
these
right.
multiple distributions here, right? Yeah, and so I said that I could say more about that. And these are the results of basically a clustering process using Gaussian mixture models. And so it was pretty clear from looking at the data that we didn't have a unimodal distribution, and obviously that's a necessary thing to have if what you care about is the exact right mean of the distribution aligning with a particular point. So in order to really fully evaluate the hypotheses, it was necessary to figure out, you know, what alignment strategies people were using in the task. And so the mixture modeling approach was used to basically figure out whether or not people were showing shifts in alignment during the course of the task, possible prosodic restructuring that's been reported in other experiments on English. And what we see is that for the most part, so in some cases, that one of the other modes may occur close to another harmonic phase position, but usually these sort of smaller, more marginal distributions are kind of, you know, may just represent some noise. So I should say the tails here are largely made up of the faster speech rates when people were naturally going to be more variable in their repetitions and less precise. So that's partly why you see kind of things looking the way that they do. But yeah, so I had sort of, one possibility might have been that you would have seen a nice clear peak at one harmonic phase position and then another one at another position. We didn't really see that so much, but we did see that like the main peak in each of these cases does occur near one of those positions.
Yeah. But I don't know. I think you could be stronger in the sense that the shape is different between panel A and panel D.
I see what you're saying. Okay. Yeah. There was overall greater standard deviation for this syllable.
Exactly.
It was just more variable overall. Yes. Yeah. Yep. Which is consistent again with what we would sort of expect. Generally speaking, you also find less temporal variability for metrically prominent syllables than non-prominent or, you know, less prominent syllables.
Yes, exactly. Great, thanks.
Yeah.
Yep. We have time for one more question, and Laura McPherson from Dartmouth College.
Hi, hopefully you can hear me okay.
I can.
This is really wonderful, Katie. I enjoyed it so much. So I had a question, perhaps unsurprisingly, about the musical part of it, and thinking about this interesting difference between the drummers, the master drummer, and the dancers, and how they were singing. So a couple of questions, I guess. The first is, are they literally singing exactly the same lines, or do the lyrics differ between what the drummer is singing and what the dancer sings? I'll start with that.
So the sort of core of the song, the core call and response is generally the same. The dancers will repeat what the master drummer has said. Sometimes I've noticed that they will kind of adjust words here and there, but it's largely the same pattern. But then on top of that, the master drummer also kind of ad-libs these additional lines that don't line up with what the dancers are doing. But the sort of core call and response is pretty similar.
Okay, cool. Yeah, I mean, that's similar to Tomaso folk music and the call and response structure. But what I thought was interesting is that, I mean, looking at your graphs about the distribution and the even and the odd number of syllables, I don't remember which slide that was.
I'll navigate to it.
Thanks. Yeah, it doesn't look like it. It looks like it's actually just the inverse, right? It's not that the master drummer is more variable. It's just that it's exactly the inverse, right?
Yeah, that's true. That's true. Yes.
So I'm wondering if you have any thoughts on, like, is there any particular functional reason that you could think of why the master drummer should be kind of like a beat off from the dancers, or vice versa?
Functional reason, you mean in terms of the function of these songs in society and what they're doing, or
I mean, is there anything about, like, you know, the fact that the dancers are dancing, or that the, you know, master drummer is presumably the one introducing the lines, or, I mean, is there any good reason of any sort why you should see the difference between an odd numbered syllables?
I don't know. I mean, probably you're right that there's more to this, and I think as we delve into these patterns more, I will learn more and probably have a better answer for you in a few months from now. But as of now, it seems to me that the sort of main driving force is that you've got this kind of line going, and then the master drummer intentionally kind of sticks out, needs to kind of rise above what's happening in the rest of the ensemble and among the dancers, to make himself heard and make himself noticed. To sort of, because he is actually serving this really important function of, for example, in some of these songs, introducing people who have come from outside to visit with the community. So that's part of what he's doing in one of these songs, is introducing my collaborator Ange by all of his traditional names, like listing off all of his traditional names and saying them. And so he kind of needs to be heard. And so there is that sort of functional pressure, I guess, to be off with the rest of the group, to rise above in that way, if that makes sense.
Interesting. Yeah, thank you.
Yeah, it seems like one more person has a question. Kubojo Sensei, do you have a question by chance?
Yes.
Yes, please go ahead. Yeah.
Okay. May I ask a general question about the language you talked about? This language has stress, distinctions between stressed and unstressed syllables. And it also has tone, lexical tone, right? What's the relationship between the two things? Only stressed syllables can bear in tones, and how many tones are there?
So the kind of predominating analysis of the tone system is it's a two-tone system with high and low tones, and then you can form contour tones by concatenating, for example, a tonal morpheme that's high with a low tone segmental morpheme, for example. But there are no contours in the underlying tonal inventory, we don't think. As far as the distributions of these tones, for the most part, Majumba is a pretty dense tonal inventory in the way that I think Larry Hyman would talk about it. So for the most part, all tones are on all syllables, but we do find some restrictions. So when you do form these four tones, and loan words are actually another place where contour tones show up, wouldn't normally happen in the kind of native inventory. These tend to be restricted only on still syllables. So contours tend to be the one thing that really prefers to be stemmal than anywhere else, but otherwise high and low equally distributed across all positions within the stem.
Is there any direct relationship between the two tones and the musical structure, the place where you have musical beat?
Yeah, great question, and it's something that I haven't investigated in depth yet. But but overall, I would say that the melodies in the music map pretty well to the tonal melodies of these words. And so if you're going from a high tone to a low tone word, you're gonna see the pitch going, first up and then down in the music. So it maps pretty closely, but I'm sure that there's more interesting things to be said about that mapping.
Thank you.
Thank you for the question.
Thank you. So this concludes the first talk, and we'll stop the recording at this point. Thank you, Katie.